to make a video for Maya real quick here. She's got a test on this tomorrow. So Maya, once again, there's two ways to do this. The back one is easier because you can just dump that into the calculator. Can you bring me a calculator? This one you have to physically do by hand, alright? There's just one there. Yeah. So I'm going to do the power rule. So it's going to give me 12 times that yellow quantity, 2x cubed plus 2. Then I have to add one, I have to subtract one from that. That's going to be to the negative fifth. Then I have to come back and take the derivative of the guts. And just throw that behind it or in front of it, it doesn't matter. The derivative of the guts is going to be 6x squared. And that's it. Now, to do this, you can actually do it totally in the calculator. All you got to do is hit the, some people call it the velocity button. It's the DDX button. Just hit that button. And you type the original in. Negative 3, parentheses, 2 alpha red x, cubed, plus 2, close parentheses. You have to add your own parentheses. That's important. You have to add your own parentheses on the inside. X box to the negative 4. Then I'm going to right arrow. And that there, that 3, is what I'm going to put in my evaluation. That's a really small number. To do it by hand, I would take that 3. I would take that 3 and I'd plug it in wherever there's an x. The reason it's a small number is because that's going to be a negative exponent. So it's going to be 12 times 2 times that 3 cubed plus 2 to the negative fifth times 6 times 3 squared. A lot of arithmetic on the calculator, but the calculator will pump it out pretty quick. On this one, we have to go back nose on and know that the derivative of ln x. Do you remember what the derivative of ln x is? 1 over x. So again, it's going to be just 1 over that. That's 1 over that big quantity. So not that big of a deal. That's going to be 1 over 3x squared plus 5x minus 10. But then I have to go back and take the derivative of what I highlighted in yellow. And that's going to be 2 times 3. That's 6x plus 5. Done. This is actually called the chain rule. It's got a name. But I'm just going to take the derivative of the outside and do 11 times that. That's going to be 55 minus 1 to the 10th. So inside of there, I'm going to re-put in the 8x to the 5th minus 9x to the 6th. And then outside of that, I'm going to tack on the derivative of the yellow stuff. So inside derivative is 40x to the 4th minus 54, yeah, 54x to the 5th. Final answer. Derivative of e. Derivative of e, that's probably the easiest one to take the derivative of. The derivative of e is e, so it's kind of stationary. But because I have stuff upstairs there, I have to take the derivative of that later on. So the derivative of 6e is 6e. So y prime is going to be 6e to 2x cubed minus 3x to the 9th. Then I have to multiply that by the derivative of this highlighted yellow part. That's it. Again, it goes pretty quick. Talking about maximums and minimums, critical numbers, this is a note that I wasn't aware of that occurs where the derivative is 0 or the derivative is undefined. I just usually deal with the derivative of 0. That's some weird higher level calculus. And here it comes. To do these, you want to have a good knowledge, you too, that y equals x looks like this. Y equals x squared looks like that. Y equals x cubed looks like this. This problem is an x cubed, so it's going to look like this. The derivative of x cubed is 3x squared, so the graph of the derivative is just going to be a u. And here's what's neat. Isn't that a maximum? Isn't that a minimum? Where that's a maximum, where that's a min, that's where it's going to be an answer. Here. That there, that answer, wherever it crosses the x-axis, is going to be that max there, and that min there. So I'm going to take the derivative of this. It's 12 divided by 3, that's 4. X a la 2. Minus 48x más 128. I'm going to set that equal to 0, and modify 3 it. When I modify 3, it'll solve that quadratic. So I'm going to type in the leading coefficient 4 equals, negative 48 equals, and 128 equals. My x sub 1 is 8. My x sub 2 is 4. I got 8 and 4. So this spot here is first. This spot here is second, because that's left on the number line. So I have a local min at 8. Now I know 8 is bigger than 4, but on the original graph of x cubed, that's a low point. Then I throw in 4 here, that's going to be my max. Now I'm trying to find the y value. They want the value of the function at that point. So what that means is for the 8, I'm going to take that 8. I'm going to take that 8, and I'm not going to plug it in here. I have to plug it in way up there into that problem. And Maya, we got to remember to put the 1 there, all that stuff. You know what I'm saying? Starts to get a little tricky. So wherever there's an x, I'm going to plug in an 8 and a 4. So the first one, I want to do the 8. I'm going to put 8 in there, I'm going to put 8 in there, I'm going to put 8 there. And that there we can type into the calculator as well. I like to do mode 7, so I'm going to type in that equation. 4/3 I plugged it into mode 7, so the 4 value is 214.33. Rapid 10. 214.33. The 8 value, that's 171.66. And we'd like to check that according to the answer guide. Does she give you an answer key to this or no?
Well, she made a video.
It should be in the video. Alright, they want me to deal with this between negative 2 and 1. I really don't need to do any calculus with this, because it's technically y equals negative 3x squared plus 8. So I know that's going to go like this, and then go downhill. Alright? I need to find out what the negative 2 value is. I need to find out what the 1 value is. And I need to find out what the vertex is. So we can do a couple of things. Let's find out the vertex first. So that's going to be mode phi 3. And that'll give us the vertex, the top part. Mode phi 3. Then I'm going to type in negative 3 equals. There's no x term, so it's going to be 0 equals, and then 8 equals. I don't need the answers. I don't need x sub 1. I need the vertex. So the vertex is going to be 0, 8. So that high point is 0, 8. Now, if I plug in negative 2, that'll give me a y value. If I plug in 1, that'll give me a y value. So I'm going to plug in the 1 there first. So 1 squared is 1. So that's going to be negative 3 plus 8 is 5. So I have a 1, 5. Now, I have no idea what's going to happen when I throw in the negative 2. So let's see. I throw in a negative 2 there. It's going to be negative 3 parentheses squared plus 8. I throw in the negative 2. That's 4. That's 4. Times negative 3 is negative 12. That's going to be negative 4. So my graph accidentally is accurate. So the absolute minimum value is negative 4. It's the lowest y value. And that occurs at the x value negative 2. The absolute maximum value is my vertex, 8. And that occurs at the x value of 0. Test scenario might say at x equals negative 2. It might say at x equals 0. I don't know what the test format's going to be. Calculus graphing is really hard. Sketch a graph of the function with the following properties. So I'm going to deal with this first one on a separate page. So it tells me that if I have a graph at x equals 1, y equals negative 1. Not there, f. That means x equals 1, y equals negative 1. So my graph is going to be at 1, negative 1, there's going to be a point. And then the slope at 1 is going to be 2. And that's a possible graph. At that spot, doesn't the graph go up 1? I'm sorry, up 2 over 1? So the slope is 2. That's it. There could be 100 graphs. You could have drawn something like this. You could have drawn a parabola. You just have to make sure that at that point, the slope at that point is 2. Different graph, different thing. So again, I'm going to do my x-axis, y-axis. At x equals 3, y equals 1, 2. So there's a coordinate. And then the slope at that point is negative 4. So I'm just going to draw a really steep negative slope line. And act like the slope of that line is down 4 over 1. That's it. Increasing, decreasing. Yo, college algebra stuff. Increasing, I'll do green. So it looks like it's going arriba, 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 increasing, increasing. It might be steady there, constant for a minute, but I don't know, it looks like it's increasing the whole time. There might be one spot in here where it's like, I think it goes straight across there. It's constant. So the graph on the right is increasing on the interval from, that's an open circle. That's an open circle there, isn't it? Let me blow this thing up. Yeah, that looks like an open circle there. That's straight across. I don't know. 1, 2, 3, 4. So that's 1.5, 1.75. It's increasing from negative 1 in a parenthesis to 1, if that's an open circle there. Parenthesis, union, starts to increase again at 1, 1.5, 1 point. Oh my god, they're not being nice. They never are in this class, are they? They give us like 1.1 and stuff like that. Some weird stuff. So let's see. That's 1.5. That would be 1 point. 1, 2, 3, 4. Let me see. 1, 2, 3, 4, 5. Let's say 1.5. It's about halfway between. Annoying. 1.5. All the way up to 9. I'm sorry, 3. X value. Decreasing? None. Point of inflection. Looks like it goes from concave down to concave up at that spot. At that spot there. So that's going to be 1.5, comma, 1, 2, 3. This is really brutal. I don't know. Let's say that's 4. That way that would be 1. Annoying. At the point 2, the sign of the first derivative is the slope of that spot positive? Yeah. So the sign of the first derivative is positive. See how it's concave up? Second derivative is positive also. Poorly written problem. I think it's just the typeset. So the note said, this is the derivative, all right? This is the derivative. How many critical points does f of x have? So where this is 0, that's how many places that how many critical points are on the graph above it. See how this is a w? That's x to the 4th. So the graph above it is going to be x cubed. And x cubed will look like this. And we have 1 max and 1 min. Right there. A max there and a min there. So 2 critical points. You really got to know your vocabulary to get those right. Is this a different review, Maya? Than yesterday? We didn't do these? I think this says it's f. So this is an upside down x to the 4th. It's basically negative x to the 4th. All right? So that's the graph. It wants to know where the derivative is positive. The derivative is positive. Where this thing's going uphill. Where it's going uphill. That's where the derivative is positive. So the interval where the derivative is positive is from negative 2.5 to negative 2, union 0 to 2. Now let's know where the derivative is negative. That's where this junk is decreasing. So it's decreasing here. It's decreasing here. So it's negative from 2, negative 2, I'm sorry, to 0, union 2 to 3. Which intervals is the function concave up? It's actually that. The derivative of that would be 4x cubed. The derivative of that would be, I'm sorry, negative 4x cubed. The derivative of that would be negative 12x squared. It's decreasing. And that's going to be 0. This is a hard one. This is a hard one. That's where it's going to be 0, 0, 0. Then this here. And that's a 0. Point of inflection. What? Point of inflection is where it goes from concave down to concave up. Alright? So we can get it from point of inflections. So notice it's concave down here. It's concave down here. Well, which intervals is the function concave up? So right there I got it. It's concave up on this little portion from here to here. See it? That's where I say sometimes it'll hold right. So it'll hold right from negative 1